Rectangles with fractional side lengths. Lesson 13. Let's explore rectangles that have fractional measurements. Okay. So today's I can use division and multiplication to solve problems involving area of rectangles with fractional lengths. So get with fractional side lengths, excuse me. So put today's date, your I can, and page number, and you're ready to move on. All right, let's warm up with the little areas of some squares, okay? So what do you notice about these? What would be the area of 1 inch by 1 inch? It's going to be 1 inch, right? 1 square inch. What about 1/2 inch by 1/2 inch? 1/4 of a square inch, right? What about 2 inches by 2 inches? 4 square inches here, right? Okay, how does this make sense though? Well, 1 inch squares, if this is 1/2 on one side, 1/2 on the other, when you multiply it together, you get 1/4. What does that actually mean? Well, that means that it's 1/4 of a full square inch. And if you think about it, if I were to take and draw lines across here at the halfway marks, I would make 4 parts to it, right? So that's how 1/2 by 1/2 ends up making 1/4 of a square inch. Here it's the same sort of thing. It's going to take 4 of these square inches to make up this 4 square inch space that we get when we have a sided length of 2 inches and another of 2 inches. What about this? Think about this statement here. Square with side lengths of 1/3 of an inch has an area of 1/3 square inches. Do you agree or degree? Do you agree or disagree? Well, I hope you disagreed because 1/3 times 1/3 would give us 1/9 square inches. And this kind of goes back to what we were just talking about here. The reason why it's 1/9 square inches is it would take 9 of those squares that measure 1/3 of an inch each side to make up a space that fills 1 square inch. And that's why it ends up being 1/9 of a square inch. Okay. All right, let's talk about some areas of squares and rectangles. Okay, so here, what do we got represented? Well, we've got 3 1/2 inches by 2 1/4 inches. Why have we marked these pieces off like this? Well, because each one of those is less than 1 whole inch. So, if we think about it, we're talking about 2 1/4 times 3 1/2, right? Well, you can think of, and this is going back to that area model piece that we have looked at in the past, right? That you've got 2 times a 3, which gives you 6 in that area. 2 times 1/2 gets you 1 square inch, right? And you can see that literally drawn out here. So we have 1/2 of a square inch because it's 1/2 by 1, and another 1/2 inch because it's 1/2 by 1, which makes total of 1 in this piece here. Here along the bottom, we've got 3, and we've got 1/4, gives us 3/4 of an inch here. And here we've got 1/2 times the 1/4 gives us the 1/8. Okay. Now, again, you can multiply the parts out. You can make improper fractions so that we would have 9/4 times 7/2, and you're still going to end up with the same thing we're going to get here. So you get the 6 and the 1 together, that would make 7. 7 3/4, and then we need to add the 1/8. So we need to turn this into eighths. So it would be 7 6/8. Oops, this is an equal sign. And then we add that 1/8, and we get 7 1/8. I don't think you can even see, or 7 7/8. Now, could we get the same thing when we do this here? Yeah, 2 times 4 plus 1 makes the 9 fourths times 6 times, or 3 times 2 is 6 plus 1 makes 7 halves. 9 times 7 is 63. 4 times 2 is 8. 8 will go into 63 7 times, leaving 56. 63 minus 56 gets us 7 eighths. So it comes out the same either way. But we can see that if we count all of this, you can see that what they've done is they've cut each part into a 16th, so that way we could end up with 1/8 here, right? Because this is 1/4 or 4/16. If we go through and count every one of these squares, we're going to see that we're going to get, if we counted all these pieces, we've got 126, and these are 16ths of one whole square. Well, if I divide this by 2, don't I end up coming right back here to the 63/8, which goes the other part? Yeah, it's exactly the same. All right, let's still keep talking a little bit more on rectangles in their area. So I've got 2 times 4, 2 1/2 times 4, 2 times 4 3/4, and I've got 2 1/2 times 4 3/4. Now each one of those matches up with one of these, but the blue is the same in all of these. How is that possible? Well, they all have 2 times 4 in some way, right? They do have other parts, so you would have to add those other pieces after you multiplied them. But they all have at least 2 times 4 is 8, okay? So if we look at each of these, C is going to match this one here, right? Because it's just 2 times 4. Here we have 2 1/2 times 4. Which one's that make? It's actually going to be D here, right? Because we have the shorter side and a little bit more, and we've got a long side that's just not changed, so that would be 2 1/2 times 4. Here we've got 2 times 4 3/4. And that's going to be A. Why? Well, it's because we have a little bit more than that for width. And so that means this one has to be B, which makes sense because it is the one that's got a little bit more on the side and it's got a little bit more on the bottom here. Okay, so using this diagram here to help us figure out why is the value of 2 1/2 times 4 3/4 11 7/8. Well, think about this. We've got here, let me zoom this in. Okay, so we have 2 1/2 times 4 3/4. We already know that this is 8, right? 4 times 1/2 is going to give us 4 halves, or 2. 2 times 3/4 is going to give us 6/4, which is the same as 1 1/2. And here we have 3/4 times 1/2 to give us 3/8 here. Okay, so if we add this all together, the 8, the 2, the 1 1/2, and the 3/8, we will indeed get our 11 7/8 because we're going to convert this to make 4/8. Which gives us 7/8. We add those all together, we make 11. So it's 11 7/8 because we can always think about those whole number pieces to get our parts, but we can still look at the other side pieces in their fractional piece and then add all those pieces together. It's the same thing we do when we do something like 134 times 22. You multiply each of those parts and then add them together. And really, isn't this just saying that you're multiplying 2 times each of those and then multiplying 20 by each of those parts? And of course, you could break it down further if you wanted to, but oof, that's pretty terrible in that writing. Anyway, that's not the focus. This is the focus. To zip through this next part here real quick. So here Noah's got a tray, rectangular tray covered in rectangular tiles. The tray itself is 11 1/4 inches and has an area of 50 5/8 square inches. Can we find the length? Yeah, because we know that it is 11 1/4 times something is going to give us 50 5/8, right? So we have to take the 50 5/8 and divide it by the 11 1/4. So we end up with 50 5/8 divided by 11 1/4. We make those into improper fractions, and we have 405 eighths. We'd have, let's see, 45 fourths, but then we would invert to multiply. We have a 4 here, and we can divide 4 out here, so that gives us 2 for denominator, 1 here. Okay, so that ends up leaving us with something we can still divide out and reduce some things. We've got 405 divided by 90, right? 90 will go into this, what, 4 times? Yeah, 360. That would leave us with 45, because 405 minus the 360, oops, that would give us 45. So 45 90ths, well, 45 is half of 90, so our answer is 4 1/2 inches. So it's 11 1/4 inches by 4 1/2 inches. So if it's covered with tiles that are 3/4 by 9/16, how many do we need there? Now this is a little bit tricky, because first we need to do a couple things, right? We need to find the area of each of those, and then what's the next step? Yeah, so the area of each of those tiles we have to take and divide it out of the area of the entire tray, so that way we can see how many would fit on there. So 3 times 9 is 27. 4 times 16 is 64. And we are going to take our 405 over 8 and divide it by those. Okay, so we're going to, again, multiply by the 64 and divide by the 27. And you can do that in separate pieces, or you can conveniently put it as an inverted fraction. 8 we can divide out of here, giving 1. 8 will go into 64 8 times. And I think I can divide 9 out of both of these, right? Yeah, because I did 90 into that 4 times. I think I can do 9 into this 4 and something times. Let's see. 9 will go into 40 4 times, because that would be 36. subtract and get 4 left over, 45. 9 will go into 45 5 times. Perfect. And I still got my 8 here. And then if I divide 9 out of this, I get 3. Oh, I can still divide a 3 out, right? Because 3 can go into 45. Oh, I could have divided that by 27. That's fun. All right. So that should have been 15. And let's see, 40. So I need 120 of those. And that makes sense because if you think about it, this is around half of a, it's a little less than half because 27/64 is 32/64 would be 1/2, right? But 27/64 is going to be a little less than that. And it takes 50 and 5/8 square inches. So it makes sense that this would be a little more than twice as many squares. So you should have had 120 for the second part here. Okay. All right. Okay, let's wrap up here pretty fast. So how can we find some ways to find area of 5 1/2 centimeters by 3 1/2 centimeters for a rectangle? We can kind of talk about what we did earlier where we used 1/16 because that would be the smallest fraction made and cover the square with 1/4 square centimeter squares. Why would they be 1/4 square? Well, because each side would have to be 1/2 because we're talking about 1/2s here. So each one of those individual squares would be 1/4 of a square centimeter. We could break down the rectangle in like the area model we talked about before, where we take and find the area of the whole numbers, whole number times the fraction here, and the whole number times the fraction here, and then the fractions multiplied together, add it all together. You can also split it up some other ways as well and look at those subrectangles and compare that with the areas of each of those parts. Kind of this is restating the whole thing just in a different way. And because we can multiply the side lengths of a rectangle, if we know one side of the area, or if we know the area in one side, we can divide to find the other one. Kind of like what we did on that last problem we just solved out. Here, if we know it's 16 1/10 overall, and one side's 4 3/5, then we can divide by 4 3/5 and get our quotient. And how do we check that? Yeah, whatever we get for a quotient should multiply by this to make the 16 1/10. Okay, time's up. Thanks for watching.